Hello, DEFCON Red Team Village. Welcome to Offensive Embedded Exploitation, getting your hands dirty with IoT and embedded device testing. So, the agenda before we start with the talk, I would like to tell you that I'm conducting a training. I would like to thank Mr. Omar and Mr. Joseph for allowing me to conduct a training with the DEFCON Red Team Village, which is on day one. So I request you to, if you like this talk, if you want to attend this in more deeper manner, you can attend tomorrow's training. Okay. So let's start with the agenda of today's talk. Today we'll first have an introduction to IoT, then we will do a preparing the arsenal, that is setting up our requirement, then we will have recon, then showtime, that is a firmware analysis, then getting hands dirty, dynamic testing, and lastly we will touch base upon fuzzing, reverse engineering and exploit development. Okay, so let me introduce myself. I am Kaustubh Padwad from India, also known as Security Beast on Twitter. I have a dozens of exploit listed on GitHub and CVE details with on IoT. Also, I'm a security researcher at Reliance Jio, that is Jio Platform now, Jio Platform Limited, where we conduct device security testing for all of the Jio Platform devices. Also, I'm a SYNAC Red team member to keep myself updated and to solve to hack into the toughest infrastructure. SYNAC is a great learning platform, and also I do bug bounty there. And I like to share my knowledge, so I'm a speaker. I speak at conferences. And now it's time to get started with the topic. So I have classified IoT in a three style. One is a industry IoT, second a human IoT, and third IoT for others, that is animal. So we'll see. I have classified here all the industry in this image is taken from source is mentioned. Here I have listed all the industries like manufacturing industry, smart government, mobile network, mobility and Wi-Fi, smart digital citizens, that is us, then open data, health is a key element in IoT, then smart agriculture and smart building, smart transportation. So these things are getting smart with the help of IoT. Major like for example, transportation industry, Tesla is the best example for IoT based car, right? Even for a logistic, IoT is getting used in very huge manner to track their shipments, that to ensure the data, the packages which is shipping should not get tampered. They are putting tamper detection based on IoT. So it's like simply if someone opens the door, that means it is tampered, and as the door is opened, that small IoT device will generate an alert and send to the respective logistic person. Manufacturing industries are using IoT to improve their services or to improve their product qualities. So should be a zero error product development, we can say, with the manufacturing industry. And government should implement a IoT. In my training I have a excellent example which I covered there in my training. So like let's assume that you every city have a street lights, hundreds and thousands of street lights, which is running from a night, which is running whole night, right? So if you install one small IoT module of let's say $5 cost to that light, then it then that light will become smart and it will turn on only when the vehicle is passing through, and rest of the time it will stay in an ideal state, let it power off state. So that $5 module can save you a $500 electricity bill for every month, right? So it makes sense of using IoT in government covered areas or government entities. Mobility and Wi-Fi, they are key provider for the IoT. As I said, in mobility, as government needs, or let's say if you want to create a IoT environment, so mobility is the best way. They provide us a NB IoT, narrowband IoT, and LTE IoT. So these two ways they can provide us IoT connectivity to everywhere. Health is the key element. We are discussing this here. And agriculture, one of my friend have built IoT based water water system to his farm. So like it detects soil dryness, it detects wind speed, it detects temperature, and accordingly it turns on his water pump. So it will automatically gives water to the plants to his farm also. And smart building, uh, there is an excellent example in the next slide for smart building. And transportation, as we just talked about Tesla. Now, in human IoT, so devices are getting inside the body. Like, for example, a pacemaker. Pacemaker is a medical device, medical IoT device. It's a really critical device in IoT aspect or in any aspect. And insulin pumps, and these are other devices which can be which is currently using inside the body. There could be a more, but as of now I collected this many. Now uh, you can trigger insulin shots to your loved ones remotely with this insulin pump. You can check if there is a what we say abnormal behavior of heart or abnormal behavior inside the body. These pacemakers are also smart. They can send data to doctor that it is not behaving good, or you can uh, as we know, pacemaker is a critical medical device. It controls your heartbeat. Now, why cow is here? So IoTs, animals are getting smarter. So like if your pet lost direction, then there are some patterns which they triggers every time if they feel like lost, or if they are not. If let's say you are not with your pet a complete day and suddenly he developed a temporary fever, then what? So some guys are working on the solution which will be a kind of belt inside their body, inside their neck, tied to their neck, and that belt will keep analyzing their behavior. Are they behaving normal? Are they feeling like lost? Is their temperature is normal? So that you can take appropriate care of your loved one pet, and you can track your animals also, like your pet also, sir. If they are lost or if they're lost, then you can track them. So IoT is a major part of our body. IoT is an emerging field, and IoT is too much powerful than we imagine. So with the great power, great responsibilities also come that we will discuss in a further section. Now let's have a look of smart building. How one can implement IoT as in a smart building. Very self-explanatory.
天猫精灵，关闭窗帘。
正在关闭窗帘。
天猫精灵，打开电视。天猫精灵，
主人，你说。
我需要一瓶水。
好的，服务员会尽快送来饮用水。机器人正在执行配送任务中，进入电梯。
The self-check-in machine, like the guest mobile check-in, like the robot service and Timogenes voice butler. The purpose of this kind of service and technology is to improve the efficiency of the service and the consistency of the service quality.
您可以取出物品了。
As you can see, a smart building, a brilliant example of smart building IoT in action. So I would definitely like to go there and check in to test the services. So with a great news, great responsibilities do come. So what I think is why IoT security assessment or why embedded devices security assessment is important. I have collected some hot news. This is IoT hot news. where we can see multiple threats and risks that currently associated with IoT. The first and most important risk here, risk with a IoT in a medical field. So when I was a kid, my grandparents used to tell us that there is a witchcraft and there is a black magic kind of stuff which can remotely kill someone. Okay, so I don't believe on that, but here you can see with IoT you can do it. Let's say if instead of giving 10 ml pump shot, if I triggers 100 ml pump shots, then who can save you, right? Instead of setting your heartbeat to the normal heartbeat, if I set it to 3000 beats per second, you will suffer from a major cardiac arrest, right? So as we can see, this are inside the body and these are very critical devices. So security assessment for these devices must be done in a very aggressive way. Like I believe that if such kind of devices are manufactured by a very renowned vendor, it should be tested countrywide. Like it should be offered to the expertise all across the globe, and then you can ensure that this product is secured or not. Because everything have a different mindset to test everything, right? So same way. Uh, Now you brought an IoT product that is a surveillance robot to secure your house and to take care of your loved ones when you are not in the home. And hackers use that robot into for spying you. Here you can see hackers break into smart home, play inappropriate music, and communicates with a resident via camera. It's a horrible thing. It's a scary thing. Like if someone is continuously watching you and someone is talking with your speakers only, how it will feel, right? It's scary, super scary. And this attack was it is an industry grade attack. Someone discovered remake of Mirai botnet. It was this OMG attack was discovered by Fortinet. It was a second Mirai. So Mirai is the biggest IoT attack till now. You can read about it. It's a really interesting attack. This is again like you buy a surveillance system to watch your home, and that surveillance system is watched by hackers. So this device was running one video talk protocol which was sending the audio, which was recording the audio by mic and sending it to the one who connects over video talk to the camera. It is again scary, right? I believe there should be some system which will ensure that how this product is secure on scale of 10. So it will be easy to judge whether we should buy it or not. Like a product rating, there should be a security rating also should be there. And this is the major threat. FDA recalls nearly 500,000 pacemakers over hacking fears. This is a really critical issue. So as you see, the life risk is associated with the risk of with the IoT devices. So that's why the security assessment of such a product is really crucial and really important. It should be done right way. Now my case study for this is, can this decent looking IP phone change into a botnet? What do you think? You can turn this device into a botnet? Most of the guys will thinking how this can be possible, or if there are experts who have already played with it may know the trick what I'm going to talk. Right now, one fine day I was thinking about which device should I pick up for the training for DEF 110 and which device should I pick up for the brief also. So I was staring at IP phone and suddenly it comes in my mind that why not this IP phone only, as every corporate have IP phone, right? So let's say our corporate is one of the biggest large corporate. So we have at least 40,000 IP phone of same brand inside our office. And Mumbai is a corporate hub. So I guess that there should be more than crores of IP phone will be there in Mumbai of same brand. I'm not talking about multiple brands. Let's say if vendor X is producing X type of IP phone, that same type of IP phone you will find at least 1 crore IP phone in the city. And if you target a specific like call center, BPO and KPO, then their business is IP phone, right? So if you target that, you will get lots and lots and lots of target. So if you are able to remotely compromise one IP phone, you are able to compromise a crores of IP phone, at least same types of crores of IP phone using this technology. So if you hacked two organizations having 50,000 IP phone each, that will create a 1 lakh, that creates your 1 lakh bots. Maybe it could take 8 days, 10 days, 15 days, but within 15 days you will get a 1 lakh computers, 1 lakh bots. Basically what IP phone is inside, it's a ARM machine or MIPS machine, right? So you may get 1 lakh bots in just 8 to 15 days. Now let's say if you target complete a city, you may ended up with 50 lakhs IP phone, right? In a city you will definitely get. Now let's say if you target a cities, multiple cities, then you can let's say if you India have four big corporate hub: Mumbai, Delhi, Chennai, and Bangalore. So if you hack even those four cities, four corporate hubs, and Hyderabad also, sorry, so these five cities, you may ended up with at least 5 crores IP phone. Now let's assume if that 5 crore IP phone, you are instructing those 5 crore IP phone to make a 10 requests per second to the facebook.com. So 5 into 10 is 50 crore requests per second to the Facebook. You think how long it can survive? Or let's say any big provider, Facebook, Google, or for how long time it can hold such a load. Even you can increase a 10 to 20 requests per second, that is around 100 crore requests per second, right? It could be a biggest task. And I'm just talking about 5 cities of one country. Now let's say if you target a multiple country with the same attack, you can create a biggest TBPS attack in the history, right? So I build a case study. How can we make this possible? But before that, we need to set up our machine to test it. Uh, most of the time when I give a talk to a conference or seminar or chapters like Null chapters or somewhere, they ask me, sir, I want to start with IoT, but I don't have enough requirement machines. So this is like, you need nothing, literally nothing to set up a basic setup for IoT testing. Here I shortlisted to get started kit. What all you need is a Linux. Why Linux? Because Linux is smooth with virtualization of ARM and MIPS devices. And all IoT devices binary, not all, most of the binaries work with the ARM technology or MIPS technology. So to smoothly virtualize it, you need a Linux. Secondly, Linux gives you lowest level access to the operating system. So if you connect a device to USB port, it will definitely give you something like manufacturer, product ID, vendor ID, device type ID, something it will give. It won't tell you like a Windows that unknown device, right? That's why a Linux. And there are more reasons which you may get in a training section. This device is the JTagulator. So JTag is an interface which some devices don't have any interface. No UART, no console cable, no USB, no LAN port, no WAN port. So in that case, what you should use to interact with device, right? Our target is to get into the device. That is our first target as an IoT guy. So in that case, what you can do is you can use JTagulator to connect with the JTag ports of the device. Now you may say, why not no JTag in the device? Because this is not the case. JTag is present in most of the devices because it is used for purely factory debugging process or factory QA process. Let's say device is in assembly line, it gets manufactured, it puts a required data, and now before going to production, device needs to done a QA. So nobody is going to check manually that hundreds and lakhs and millions of devices with manually checking one pin. No. What it do is it will connect the JTAG pins to the device and it will test all the functionality with their JTAG testing suite. So JTAG is present. You may not find the JTAG pins on the device, but you will find the points where you can solder the pins and you can connect a JTagulator and identify the appropriate JTAG pins. Now, as a IoT comes in a mind, second thing comes is a wireless. IoT gives you a wireless freedom. So like now the device, two sensor and one server is not connected over wire. These will be connected with a wireless technology. For example, were Zigbee protocol, Z-Wave protocol. So to test this kind of protocol, we need some specific hardware which will identify those frequencies. So this API Mote is a gadget which can which allow you to perform a Zigbee testing, like Zigbee packet injection, Zigbee packet replay attack. So you may see building lights. These are controlled. Most of the lights are controlled by Zigbee. And connectors. Finally, they are live. You will means without connector you cannot test IoT. We need at least one extra LAN card. We need at least one WAN card. We need an additional Bluetooth adapter. We need one screwdriver set. We need a SCADA because SCADA is all-in-one connector. So instead of spending for individual connectors, if you can spend, that's fine. But instead of spending on this multiple, you can buy one SCADA connector which supports GPIO communication, which supports JTAG communication, which support UART communication, and also SPI communication. So if you buy this one product, your all problem will get solved. And lastly, to hack the radio frequencies, we need an hack RF device. So this is the minimum thing you need to get started with the IoT testing. Okay. Now this is a basic setup. Now what about advanced setup? This you can buy endless stuff. As new device will come, you need to buy something. As new device may have other way to communicate, you have to build your own PCB boards to communicate with that device. So there was one device which is not directly connected over USB. So there was a mediator chip in between. So like you have to connect that device to that mediator chip. That mediator chip was converting those signals into UART and then UART to USB converter and that to laptop. So this was a complete set. So there is no limitation for advanced setup. You can build up to whatever you want. Now we are done with the hardware part. What about software? Which tools are required? Are those tools are expensive? Are those tools are paid? Are those tools are really too much heavy that one cannot afford? No, this is not the case. This I called as a weapons, and these are the minimal weapons which are needed for testing. One is a binwalk. So binwalk is a great tool. You can do a firmware extraction. Binwalk is basically give a firmware to binwalk. Binwalk will extract you if there is a unencrypted firmware. Okay. We need a Firmadyne. So Firmadyne is a collection of multiple tools. The Firmadyne consists of binwalk, QEMU, and Postgres database, and it's a properly organized framework for emulating the firmware. Okay. So we need a Firmadyne to emulate a device firmware in case you don't have a device and if you have only the firmware and you want to test it. Burpsuit, I hope everyone is familiar with it. Burpsuit is the great proxy tool we have. And we need a Python because most of the tasks we have to do it on repeated basis. So to automate that stuff, Python is the great and easy to write language. And lastly, IDA Pro. So if you can't afford IDA Pro, it's okay. You can buy IDA Community Edition or you can use some open source tools like Radare or NSA Hydra. Also, NSA Hydra is also a great tool to reverse engineer. But trust me, reverse engineering is the life. Reverse engineering is the life, and reverse engineering is the most important aspects of device. So there are few things that comes in a mind when someone asks why you need to reverse engineer the binary. Hard-coded backdoor account. Some devices recently, when there is a news called on I forgot the name of that router OS, but that router OS as having seven major issues was recently identified, and most of it was a hard-coded backdoor account. That too listening on a WAN interface. So let's say if your device is running a telnet on WAN interface, and if there is a backdoor account, you never know how one can enter in your network. So this is one aspect. Second is identifying the critical vulnerabilities, like so remote code execution. As in embedded device, there is very limited space, so you have to fit everything in that small space. So application logic and application code is inside the web application binary only. So once so to identify that binary, the best way is to reverse engineer that binary and get assembly code out of it, and then perform a assembly analysis to identify where the native vulnerable calls like sprintf or system call, fopen, popen kind of calls are in use. Okay, so to reverse engineer we need a IDA Pro. Now let's move towards, once you have set up everything, we start with the first stage is always the recognition of pen testing, right? In IoT also it's not exceptional. It is first stage is recon. I split this recon section into two parts. First active recon and second passive recon. So generally in pen testing we perform active recon first and then passive recon. Here we have to do reverse. Like first we have to do a passive recon. Let's say if you got one device, for example this headset, and now the manufacturer of this headset is saying that this device does not support a Wi-Fi. So how can you ensure it? Just because he said this doesn't support Wi-Fi, you are going to believe that this doesn't support Wi-Fi? No. You have to read their specification. So each device have one unique FCC ID. And if you search that FCC ID into the FCC ID database, it will come up with all the specification are exist with the device. Okay, so sometimes vendor may lie to you that this functionality is not supported at hardware level, and they can disable it. Like this happens with me with one product, that that vendor was saying, sir, this device doesn't support Wi-Fi, and on FCC ID device they have mentioned that this device supports Wi-Fi. So we had a long debate, and lastly I ended up with creating custom firmware which loads the Wi-Fi driver. So basically they just disabled the Wi-Fi driver. That's why Wi-Fi is not coming up of that device. Okay. So first we have to do a FCC ID analysis. Second, documents. You should ask for as much as possible documents. So like that document could be a security architecture document. That document could be a product data sheet. That document could be a project description sheet, or could be a user manual of the product. Okay, so these are the things that you should do first, and then you should touch to the device. And then once you touch to the device, first thing is to know your device, right? So if I give you something like you have to test this device, what you will do? Like in web application, we see what technology it is built on, like LAMP stack is there, or what are the directories are in use, what is the server. So same way in device security testing or IoT pen testing, we have to identify the multiple entry points to the device. For example, a LAN port. In this device there is a LAN port, there is a console port, or there could be a Wi-Fi this IP phone might be using, and some like if device is running on Android, there could be a ADB running on it. Some advanced devices that I told you one about narrowband IoT, they could be using an IDD interface to communicate with a server. No IP network, basically no IP data delivery network. Okay, and then you can check for the UART. If UART is present, console port is present. If Android is there, then ADB is present. If classic ports are there, then LAN port is there, console port is there. So first thing is to know your device. How can you interact with that device? How can your Linux, your pen testing machine can interact with the device? And once you know that you can interact with device with specific way, you should go through the documents. So here are some glimpses that will help you in identifying why document review is important. So here in this document, vendor is saying that this device supports SIP version 2 and RTP. That means this device does not support SIP TLS, SIP TLS. So if someone is able to sit in the MITM attack, he could able to hear your traffic, hear your call, which you had word with. Here you can see this device support TR069. So most of the classic guys who is working on Windows, on Linux, on network pen testing are not familiar with the TR069. So TR069 is the protocol through which you can provision or reconfigure device completely using ACS server. And here is a user. I'm sorry. Here is a user manual. That user manual tells us that firmware of device is upgradable. Device have a password management. Device have a local and remote syslog. Device is having auto provisioning using TFTP, HTTP, and HTTPS, and also multi-user level. So if owner of device have changed the password from device to admin to admin at 123, still though it's guessable, still there could be a multiple users like support, like tech, this kind of user you may find generally inside the product, and their password will be same as the username. So this you can identify from the uh, manual itself. Now this is one algorithms. Reviewing algorithms is one of the most critical part in IoT. You may be thinking what we have to do with an algorithm. So the practical example for this is, let's say vendor X have decided to produce a routers. So as per the standard or minimal requirement, all routers Wi-Fi SSID should be unique, or Wi-Fi SSID should be random, or at least the password to connect that SSID should be random. So how you think that for 1 crore devices, how you are going to do a password? You are going to write a C program for that? No, right? Or even if you write, so you are going to maintain the unique password for every device with you? No, right? So what you are doing here is you are using one algorithm to generate a SSID password. So basically, first 4 digits of your MAC address and uh, last 4 digits of your serial number plus current date and time could be a password for SSID. So if you search for the uh, Belkin password generation algorithm hack, you may come up with a what you may get what I'm trying to say here. So if they design the poor algorithm just by adding first 4 digit of MAC address, last 4 digit of serial number, anyone can generate a password for any device, right? Or MAC address plus date on time. So like you know that if vendor X is generating a password based on MAC address and date on time, so what you do is you set a packet capture, you capture a beacon, you get that MAC address first 4 digit, and you add a current DDMM format and connect with a password to the SSID if the SSID is on default password, right? So to ensure that they are not doing such a silly mistake, we have to review the algorithms. And lastly, the magic number. So what the magic number is? You found some fault in your device, for example, set-top box, or for example, in any of your device. Let's say router. If you are a non-techie guy, you take that router. Hey man, this router is not working. It's not showing up. You take that router to the respective service center. That service center guy connects to the router and enter some to code, and in 15 minutes he will give you that, sir, it is working again. So how you think it is possible? So every device have some specific additional access mode that we called a what we called it, developer mode, or debugger mode, or engineer mode. So to access those modes, you need to enter some secret code, which is also generated by algorithm. So it calls a magic number generation algorithm. So you have to read it. Like there was one USB which was supporting, which is locked to support with specific ISPX for internet providing, and let's then you want to unlock it and you want to use it over other network. So how you can do it? You access the engineering mode of that device, you remove that restriction, maybe a plemon lock is there, maybe some MNC code or whitelisted inside that device, or it could be a single only name of ISP is written there to latch on this network only if you find. So you can easily modify it. So to access this additional modes, you need this magic number. So magic number generation logic should be tough to identify. Like otherwise, once this logic is leaked, you are over. Now, this is the most interesting aspect of document review. A credentials to access the device. Here you can see funny part, default PC Pro port connection type is bridge. Okay, that's fine. Default username for user mode is admin. Default, for admin mode, it's admin. Okay, that's okay. Default username for user mode is user. Default password for web is null. Wow. Like they set up a complete web UI. They set up a users. They set up a password policies. And now they are setting password to null. That means all you need to do is you have to identify the IP address. Once you identify the IP address, you type admin and you are admin. You type a user and you are a user. Isn't it so funny? And here is a default web login port. So they are giving you everything in their documents. So you should review those documents. You should search for the word like ENC. So if there is an encryption logic, it will pop up. You should search for the word SECU like CQ. So security related stuff is there, it will pop up, because sometimes user manual is of 400 to 500 pages. To quickly review it, as if you are a device tester, you may get a limited time of 5 to 10 days to complete one device security assessment. So in that case, you need to follow such kind of tricks. Now, active recon of the device. So active recon here is not just identifying open port. Okay, but when it comes to open port, you should do a port scan of all port for device, because they always use non-standard port. Here is one device which I scanned. This was the IP address of it on 2017. I did scan on this device Monday, and I found this port was open 1380. After reversing that binary which was associated to this port, I was able to perform a remote code execution on this device. And this is an end user device, so multiple users is having access. So I could have execute a code on maybe 70,000 people in a city. Same way, I discovered this crash on 4046 port. So if I fired one command on random IP addresses, so wherever it connects to 4046, those devices will get crashed, and I could cause a disruptive denial of service attack. And this was also an interesting crash I identified on 415654 port after reversing that binary. Oh, I forgot to hide this MAC address. That's okay. So this is active recon, but we don't stop here for recognition. We have to identify what is the underlying OS of this device. So let's say you saw of one fine working Android TV. So you know that underlying OS is Android. Now what about IP phone? What do you think IP phone is running? IP phone, mostly all of this embedded device runs on a Linux. And they use Bsides as a kernel and Bsides to save the space, because as I told you, we have a very short space associated with it. So to save space, we have these embedded devices uses Bsides. And why Bsides falls in a recon? Because Bsides itself has some vulnerabilities. So if you search CVE details for Bsides, you may end up with a vulnerability. And underlying operating system will tell you what are the vulnerabilities are associated with that operating system. So basically, if say the device is using Linux kernel of version 2 to 2.10 to 2.15, then in these 5 versions there could be lots of vulnerabilities which you can exploit later. So identifying underlying operating system, identifying a Bsides version, identifying all open ports, TCP, UDP, and apart from this, what we can do is like accessible locations, like let's say consoles. If root console is running without password with a UART, all you need is to connect one cable using UART to USB converter. Okay, so this is an active recon for embedded devices. Now we will touch base some more aspects of recon in our upcoming training. Okay. Now, the great part of device testing is when you are testing device as a white box approach, you may get with a firmware. So there are two types of firmware basically: encrypted firmware, compressed firmware. So agenda for this firmware analysis talk is to identify what is firmware, obtaining firmware, ways to obtain the firmware, unpacking firmware, and finding vulnerabilities inside the firmware. So here the best part of device testing, if you are doing a white box, then you get a firmware. So that will help you the identifying the directories or entry points or network services running on it using the firmware itself. So you don't have to do just a brute force using FFUF, or you don't have to do a content discovery in a very large way. Like, you have to perform analysis here, not a content discovery. So that section get really skipped from recon, and here you if this is a white box testing. Okay. So what is the firmware? Firmware is the file which contains a file system of device, a kernel for the device, and a bootloader. And this firmware are of two types. One is a full firmware, second is a delta firmware. So let's say you are using a mobile, like I'm using a Samsung mobile. So you are using a Samsung version, firmware version 1.1. Now, there was an issue when you open a dialer, it gets crashed. So this is a small issue, maybe developer messed it somewhere. Now Samsung want to send an update. So do you think Samsung is going to send you a 3 GB update for complete operating system for one small patch? No. What they will do is they perform the respective changes at file system layer, if it's a file system level. Then that delta part they will calculate of KBs and MBs, and that will ship to your device. So that is called a partial update. So that is a delta firmware, and that firmware you receive over the air to your handset for update perspective. Okay. So these are the types of firmware. Now, what are the ways to obtain the firmware? So here are a few ways I listed down. We are going to touch base on more ways in a training. So first is downloading from the website. Like here you can see the firmware is listed on their website. You can click on download, you will get a firmware, complete firmware. Second is, like, you set up a bridge, like this is your device. This is the LAN card of your PC. This is your additional LAN card. You set up a bridge connection, and this is your ISP cable. Now on device end, click on check for update. If there is a firmware available, start Wireshark capture here on your bridge and click on download. So what happened? That capture will get stopped here, and you can download the firmware from the update. Now extracting for a device. I told you, like, some device don't have literally any way to connect with a device. So in that case, you can connect a JTAG and you can dump the firmware using JTAG. Then Google Docs. So like if you search index of or FTP of a product name, you may come with a firmware. And lastly, analyzing device traffic. So believe me, some devices, most of the devices which we use, like smartwatch or a mobile phone, gets a silent update. So what that silent update is, device is checking periodically whether the firmware update is available or not with a respective vendor. So let's say it on one fine night, device checks for the update. Now that update requires restart and device is restarted. So I woke up with my phone and saying why my phone is restarted, whether as it was charged full. How? So these are the tricks that vendor push the firmware silently. That is called silent update. So to obtain such kind of update, you need to keep eye on device traffic. So basically, you can set up one interception server itself, so that all the device which are at your home are connected to that interception server, and that server is downloading everything from you can have a track of all the things that is getting downloaded at your home. Okay, now you got a firmware. What now? So everyone knows that binwalk hyphen you can extract the firmware. No, that is the most inappropriate approach to extract the firmware. First thing you should do is an entropy analysis. So some firmwares are compressed and some firmwares are encrypted. So if you run a binwalk on encrypted firmware, it will create a garbage. It may literally fills your GBs and TBs of data with a garbage and you will get nothing. So first proper way is to perform an entropy analysis on firmware with binwalk hyphen capital E. It will generate a graph like this. As you can see here, a line is completely on the one. That means the firmware is very nicely encrypted. But here you can see some part is here is not encrypted. So now what? Now we can run a DD on this part and we can download this particular information to our device and we see what is there present. So believe me, once I found a private key to decrypt that firmware in this part. Once I found a password, so that is a fun to identify the firmware entropy. And with that password, I was able to open that firmware. Now, to sometimes in Hexdump only you will see the password of firmware. It happens to me, and then you can perform a signature analysis. So, like if you are able to perform a signature analysis, you may come up with knowing which type of file system are in use. So, like in Windows we have FAT, NTFS. In Linux we have XT, XT1, 2, 3, 4, and Razor FS. And same way, in device you may never find this FAT and ext code. You will find operative file system like CramFS, UBFS, SquashFS. SquashFS is majorly I have seen till now, and YZFS. So these are the very small file systems are in use because due to the restriction of space. Okay. Now, once you are able to extract the file system from the firmware, now what to look inside it, right? We are going to touch base details aspect of this in our tomorrow's training. But as of now, what are the most critical aspect that you should look? First, obviously a passwd file to get a credentials and decode that hash to log in inside the device. Second, you should look for the document root. So what are the web pages are there? Some hidden pages which is not listed in GUI. Those hidden pages may use to access a device core functionality or execute a root level command. Then, as I told you, in this application binary and the application logic is built inside the web binary. So that binary should be downloaded and reverse engineer for the purpose of identifying vulnerability. And lastly, this is the first command which I run on firmware. Find /name.sh with the type of file and having permission 777. So this is the most important aspect. As you can see, there are cron jobs running with a root, and that was a shell script, and it was having a permission of 777. What you want? You are root now. You can edit that shell script, put add user command, and once that script is run by cron, you get a add user. Your user is added, so you can backdoor that device. Or as it a 777 and having sh type, so you can execute it yourself, right? So this kind of interesting stuff you can look. What are the shell script files are there? You can look up for the email addresses. We are taking this in little deeper manner in tomorrow's training. So these are the crucial part of firmware you should look for. Now, here in document root, you may ended up source code review for web application completely. And in application binary itself also, you can review source code review of the application binary to execute a command from a web interface. Now getting hands dirty. First thing is like obvious, you are running a port scan. So once you remember we conducted a document review where we found a default credential is admin. Now I ran a port scan on this one fine device, one fine IP phone. It was an IP phone, and I found that telnet was open, and simply connecting to telnet and running admin, I got this. Here you can see UID 0, GID 0. We got a root over this device just by typing admin. Now we see that 80 and 443 is running also, as we know that web server is running on document. I found this two new ports from port scan, that 7547 is there and 53 is filter on the device. So generally this device don't have a capacity to host a DNS server, so they use a very fine utility called DNS mask. Almost in every device you find a DNS mask which is running on a port 53. That DNS mask itself acts as a DHCP server also in device. And I found one new port that is called 7547 port. So after studying a lot, I come to know that that is a CWMPC port which was doing a device management on 7547 port. And here you can see operating system is Linux kernel 2.6. Just Google about the Linux kernel 2.6 exploit. I believe you may find a 5 to 6 pages of CVE details with the exploit available on the device. And here is a specific version 2.6.17 to 2.6.36. So you may find more critical vulnerability, and now you have a deeper angle and you have deeper aspect. So all you need is to look into 17 to 18 exploits, like 18 versions, and exploit for that 18 version only. So you may use it for a remote code execution if exploit is supporting RCE, or you may end up with a privilege escalation vulnerability. Now, obviously, as we seen in a port scan, the device is running web server. I connected to that device and found this index.asp. I entered username and password. Here you can see username is traveling and password is traveling. But what? I think something is missing here. So what is missing? That missing part is nothing but a xframe option header. Now you are thinking why I am making a critical issue, why am I marking this as a critical issue. I'll tell you in a next slide, next few slides. But keep in mind that we have no xframe option here. So that means these devices are vulnerable for clickjacking vulnerability. Okay. Then after further accessing or after further obtaining few from this device, I got to this one request, that this one request could manage a complete device. So I can, with this one request, I can manipulate every parameter of device. Here you can see user type is admin, user name is admin, admin password is admin, then DBIDC LCD language is 0, management use VPN 0, remote web login is 1. That means remote web login is enabled or disabled. Okay. So you can change it also, as you have a in one request only. Wireless access 0, LAN port is 80, DBID web port is 80, DBID web SSL port is 443, and remote legal IP is everything. So every remote web is legal IP. Then remote telnet is 1, telnet security code and telnet local telnet is 1, telnet port is 23. Telnet remote legal IP is 0.0.0.0. So anything, any characters, anyone can connect to device over a telnet, as this device is listening on 0.0.0.0, and hostname was there, radius access is there, IP phone syslog enable, device management. So as you can see here, everything is controlled in just one request. Okay, and can you notice something here? So this is an interactive session. Generally, I'll tell you, there is a no uniqueness in this request. As you can see, apart from these cookies, there is no uniqueness. So that means this device is vulnerable for request forgery also. Now we have a clickjacking vulnerabilities and request forgery vulnerabilities. So we can do a cross-site request forgery to this device. Now let's look at last part. Here these devices have some one page called diagnostic. to perform this kind of operation, like to ping the device or to see whether the device is properly configured in a network. So like you can't do the SSH to the device and ping for the device. So these guys generally give such kind of option in web UI. And here you can see here was a ping option. I just put a id command in backtick and it returns me id. So basically we have a remote code execution vulnerabilities, or say code execution vulnerabilities on the device. Now we have a clickjacking, we have a cross-site request forgery, and we have a code execution. Now if you put some logic that this is an IP phone, it is connected to the laptop. Now laptop is directly connected to IP phone. In most of the company, wherever you see, IP phone network and laptop network are same. Generally, IP phone itself gives IP to using that cable to laptop. So that means your laptop is reachable to IP phone. Now let's make some fancy page of to retain this organization employment. You have to agree to policies. Means to continue with employment, you have to agree those policies. If you don't want to, if you want to get terminated, you can, or in case you want to leave the organization, you can click on I disagree. Now add a clickjacking. Using clickjacking, make a request to the IP phone with a default credential. It works most of the time. And instead of that ID parameter, change that value with a curl facebook.com, or let's say let's add a cron job. Let's add a cron job using command execution vulnerability, like for I in 1:100 do curl -ik https facebook.com, or any website, for example .com xyz.com. And once this request is fired, that bot is under your control. Or you can add a backdoor to the device, and those will become your destructive bots. Isn't it easy? This is how we can turn a simple IP phone into a botnet. That's all. Here is the POC which I done on my laptop, and this was connected to a laptop IP phone. I just clicked on I agree, and it executed ID command this many times on the device using this simple web. Now what I need to use this, I need to host this test POC to one server, and all I need to do just send that server link to anyone. And means to send that server link to users, so that once users click on that link, it will create a, using clickjacking, it will create a request to device with a CSRF and default credential and command execution. It will authenticate and executes the command. Okay, so this was all getting hands dirty with IoT. Now we will touch base upon fuzzing, reverse engineering, and exploit development. We have a complete 1 hour section in tomorrow's training, or in my training at day 1 of fuzzing on this fuzzing, reverse engineering, and exploit development. In this brief, due to lack of time, we are just touching base on this. So first thing is to get the shell. Before we start fuzzing or debugging, we need to install the debugging tool on the device. So for that, we need to get access to the root, or we need at least some shell to device for testing this. Second, what are the ways to obtain this shell? It's like one I demonstrated just now with a web vulnerability. Instead of ID command, you can execute npf and lvp on 4444. You will get a reverse bind shell or reverse shell, bind shell to the device. Second is firmware analysis. In firmware analysis, you may come up with a hard-coded account, backdoored account, or you may come up with a way to execute a command. Some binaries might be there which is listening silently, and there is some clients to connect that device. Third is document review. In document, they mention that in case of emergency, you need to connect on this port by this way or by pressing this button multiple times. you may get a shell. And last, default credential is always good, and reverse engineering the binary. Default credential we used in earlier our telnet server, and exploiting web vulnerabilities also we use right now. And lastly, reverse engineering the binary. So this looks complicated earlier, but when I start exploring this, it is not as complicated as it is. So there was one fine admin panel. I just put admin on it. I intercepted this and I found this. These are the request username, log off, login time, login time 0, and login value, password, wrong password, password 2 is wrong password. This is the input I typed here, and again there is a user password is wrong password. So I saw multiple fields there as a password, and I decided to first then make sure whenever you are fuzzing a device, you should fuzz each and every request. You never know when you got a surprise. Okay, then I created this fuzz list here. A 2 times A, 5 times A, 10 times A, 20 times A, 50 times A, 100 times A, 200 times A, and I loaded it into burp-sol payload, and I fired this into there. Now here you can see this is a missed part. Here you can see the responses is here, but here it is missing. Again, the device started responding. So let's see what happened in the background. Here is a log of device. What you can see here. Can you see something interesting here? So the Boa server was running here. Then there is an extra body. It got what it got? 6 a buffer overflow here, a static buffer overflow, dumping core/tmp. Now what? Again Boa server started with a different PID 1170, 1169, and what here? Extra radial body. Again it got 6 up. Again dumping core and TMP. Now again it got crash. Again it started. So someone might be wondering that if we are able to crash, if the device is getting crash, how this binary is getting up? It's because there are procmons kind of activities are running inside the device, which will keep eyes on process. Like if the web interface is up or not, if the SIP interface is up or not, if a LAN interface is up or not. So whenever we are crashing this with our payloads, as you can see here, here when we send a 5000 A's as a password to the device get crashed. Again we send it 10,000 A, it is getting crashed. Again we send 20,000, it is getting crashed. Again with the 50,000, it is getting crashed. Okay, so this is how we are getting crashes here. So first thing is once you got a server, you need to first all each and every request with each and every parameters. You may get a surprise anytime. So this is a fuzzing with HTTP section we are doing now. Now you got a crash, right? But you have to identify at what level device is getting crashed. So here you may see when you are sending a 5000 A, their device is getting crashed. So what you have to do now with the MSF, you have to generate a payload of 5000, and you have to copy that payload into a request, and you have to send that payload to identify those offsets at which point device is getting crashed to develop a successful exploit. Now how you can achieve it? So first thing is as you have a root shell, first thing is to grep for the process ID, which process is running. Now you have to install the GDB server. We are taking this in deeper manner, that how we are going to install a GDB in training. And you have to attach the process here with GDB. Now GDB is listening to this process, and then you have to connect GDB. Means we need a GDB multi-architecture here to connect this. And once you connect it to GDB, you have to regenerate the crash. As the device is crash, you can see here the registers from GDB. It's a PON GDB I used to use. As here you can see from register S0 to S3, these 4 registers are in our control. Then here you can see a T4 register and T7 register are in our control, and also we have a control over return address. So once we got this much of access, now you know what to do, right? Just get a dirty shell code for reverse shell or bind shell and fire it. And once you fired it, you will get the device. So this is the owning the device. So here is an exploit, which a simple exploit I developed here for this IP phone only. Here you can see username is buffer overflow and the password is equal to a into 999 times. This is the padding till T4. Then first register comes as T4. Then again we have a T7 here. Then T6, and here you can see S0 register, S1 register, S2 and S3 register, right? So all you need to do is you have to host this register here in S0 to S4, and then you have to give some padding here again till return address and some padding, and then you have to call the return address. And by this way, you can own the device without any interaction, just by knowing the IP address. All you need is IP address once you perform an extensive research to this. So as I am available with you from long time on this sort, still you have a question, you can mail me at kingkaustubh@me.com, and you can follow me at Twitter at SecurityWeek. Thanks a lot. Hope you like this talk, and hope I can see you again tomorrow again for tomorrow's training. Thanks a lot. Thank you, Mr. Umer, for giving me an opportunity to present my talks at DEF CON Red Team Village. Thanks a lot.